Ever been in that spot where you need to get up to speed on something technical, like really fast,
Mhm.
maybe prepping for a big meeting or jumping onto a new project or just, wanting to level up? Well, today we've got you covered. We're doing a deep dive into Adobe Experience Manager, AEM. We're focusing on some really fundamental concepts, things any developer using AEM really needs to have locked down.
Exactly. Think of this as your shortcut to understanding the core building blocks. We've got these practice questions here, and they're actually a great way to explore these key areas. It's all about getting those practical insights, those aha moments, without getting totally lost in, the super technical stuff.
Right. Our mission here is to make this stuff not just understandable, but memorable, actionable for you. So let's dive right in. The first question. It tackles something pretty important for keeping control over the authoring experience.
Okay, first one. Which mechanism should a developer use to ensure a custom component is only available to specific templates in AEM? And the answer we're looking at is B, defining allowed components in the template policy.
Template policies. Okay, yeah, you hear that term a lot.
Yeah.
So just break it down. Why is that the best way, defining them in the policy?
Well, think about site governance, right? AEM's editable templates, they give you this really solid framework for page structure for behavior. And template policies are a key piece of that. They let you dictate exactly which components can go into specific spots on a template.
Ah, okay, so for certain layouts within the template.
Precisely. This makes sure things are consistent across all the pages using that template. Imagine a huge website, right? These policies become, well, crucial for keeping a unified look and feel. And it stops authors from accidentally, breaking the design.
That makes perfect sense. So it's not just locking things down, it's guiding the authors within, like safe boundaries. Okay, so what about the other options then? Why aren't they quite right for this? Like A, sling.resource supertype, or C, custom dialogues and apps, and D, configuring in rep.policy.
Good question. So, sling.resource supertype. That's really about inheritance between components. You use it to build on an existing component, not really restrict where it can be used on a template.
Got it. Inheritance, not placement control.
Exactly. And custom dialogues and apps. That's all about the authoring pop-up for the component, the fields and settings inside it. It doesn't control where you can actually drop that component on a page.
Right.
And red.policy, that's much broader. That's repository security, access control lists. It's not about this template-specific component availability we need here.
Right, different level entirely.
Yeah. So those other things, they have their uses, definitely important uses, but for controlling which components go on which templates, template policies are the tool.
So the key takeaway, template policies are your go-to for that fine-grained control over authoring, right at the template level. Keep things consistent but flexible. All right, next up, let's talk performance. Keeping our AEM instances running nice and fast.
Okay, question 2 dives into performance analysis. What tool is recommended to analyze query performance and indexing in AEM? And the correct answer here is B, the Query Builder Debugger. You find it at libsearchcontentquerydebug.html.
The Query Builder Debugger.
Yeah.
Sounds pretty specific. What makes it the top choice for this? What does it actually show you?
Well, what's really great is that it's purpose-built for exactly this. You can literally paste your AEM queries into it, run them, and it gives you a detailed execution plan.
An execution plan, like how AEM actually finds the data.
Exactly. It's like seeing the roadmap AEM uses. It shows you which indexes are hit, or maybe more importantly, which ones aren't being used, and it highlights potential bottlenecks in your query. This is, invaluable when you're trying to optimize slow pages or figure out why a search takes forever.
That sounds incredibly useful, seeing under the hood like that.
Yeah, it's not just about if a query works, but how efficiently it works.
Okay, so what about the others?
Yeah.
CRXDE Lite A, the AEM Web Console C, and the Index Stats Console D. Where do they fit in?
Right. CRXDE Lite. That's your general repository browser. Great for looking at content, nodes, properties, but it doesn't give you that deep dive into query execution.
Okay, more for browsing.
Yeah. The AEM Web Console, that gives you the big picture system, health bundle, services, logs, that kind of thing. But again, not that specific query analysis.
Right, overall health, not specific queries.
And the Index Stats Console. That is useful. It tells you about the overall health and usage of your indexes. It kind of complements the Query Builder Debugger, but it doesn't let you test and analyze specific queries in the same direct way.
Gotcha. So for pinpointing those query performance issues, the Query Builder Debugger is really the dedicated specialist tool.
That's the one.
Good to know. It's all about understanding the how of data retrieval. Okay, moving on. Let's talk cloud service. Configurations for different environments. Critical stuff.
Yep. Question 3. What is the correct folder name for storing OSG configurations for the author run mode in a cloud service environment? And the answer is D, apps mysiteconfig.cloud.author.
That naming structure looks very precise. Config.cloud.author. Why both .cloud and .author?
So in AEM as a cloud service, configuration management is very structured. It has to be, right, to keep environments separate and working correctly. The config part is standard for OSG configs. Adding .cloud specifically marks these configs for the AEM cloud service environment.
Okay, so .cloud means cloud service only.
Right. Then adding .author specifies that these particular settings should only apply to the author instance. This layered naming makes sure the right configs land in the right place, the right environment, the right instance type. Super important for stability in the cloud.
It's like a very specific address for your configuration file.
Exactly.
And what happens if you mess that up? If you don't use that exact naming in cloud service, what are the pitfalls?
Well, if you use the old style, maybe just config.author like in AEM 6.5,
Yeah.
or try to add something custom like .dev that isn't a real cloud service run mode. Those configs probably just won't get picked up. They won't be applied correctly in your cloud author environment.
Ah. So things just won't work as expected.
Right. Features might be broken. You could get weird behavior on author, maybe even deployment failures. The cloud service platform really relies on the strict naming.
Okay, so lesson learned. In AEM cloud service, that folder structure isn't just a guideline. It's pretty much mandatory for things to work.
Mhm.
Right, next up, let's switch to something developers often like, sling models for getting back-end data.
Question 4. How does a developer define a model class so that it can be automatically injected via Sling models? The answer here is B, annotate it with @model-adaptables-resource.class.
Sling models, yeah, they really streamline things. For anyone maybe less familiar, what does that at model annotation actually do? What's the magic there?
So the @model annotation, that's basically the signal to AEM. It says, hey, this Java class here, it's meant to be a Sling model. Then the adaptables part tells AEM what it can adapt from to create your model instance.
Adapt from.
Yeah. So resource.class means AEM can take a JCR resource, the content node in the repository, and automatically adapt it into an instance of your Sling model class. This lets your templates, like in HTML, easily get at the underlying content without you having to write loads of boilerplate Java code.
Ah, okay. So it connects the content node to your Java model class.
Exactly. It's a really clean way to separate your presentation logic, your template, from your data access logic in the model. Makes code much easier to manage and test.
Nice. So it's like telling AEM, see this resource. You can automatically make it into one of these model objects I define.
Pretty much, yeah.
Okay, so why not the other options then? Option A is at component, C is adding to config.xml, D is manual OSG registration.
Right, so @component, that's the standard annotation for making any OSG cheese service. A Sling model can be an OSG service, sure, but it's the @model annotation with adaptables that specifically marks it as a Sling model for that automatic injection magic.
Okay, at model is the specific key.
Exactly, adding stuff to config.xml. That's not really the modern annotation-based way we do Sling models. And yeah, you could manually register a model as an OSGI service, but honestly, using the @model annotation is just much cleaner, more declarative. It's the standard practice.
Got it. At model with adaptables. Elegant, concise way to link back-end data to your front-end templates. Okay, now let's talk about those really useful pre-built tools AEM gives us. Core components.
Question 5. What is the correct way to reference a core component inside a custom template? And the right answer is B. Include it via the proxy component in Apps Your Project component.
Right. Core components, they're a huge time saver. Why is this proxy component approach the recommended way? Why not just use them directly?
Well, using these proxy components gives you a fantastic mix of flexibility and maintainability. It's actually pretty smart. Instead of pointing directly to a core component, say from libs in your template, you create this lightweight component in your own project's apps folder.
Your own component that points to the core component.
Exactly. It has a property, sling.resource supertype, that points to the core component you want to use. It acts like a proxy, right? And the beauty is you can then customize your proxy component. You can change its dialogue for authors, apply your project's specific CSS, maybe even slightly extend its logic, all without ever touching the original core component code in libs.
Ah, so you keep your customization separate. That sounds much better for upgrades.
Precisely. Upgrades become much, much smoother because your stuff is
So
separate.
it's like getting your own tailored version, but still built on that solid core component foundation.
Yeah.
What about the other ways mentioned? A is data sly use, C mentions an HTL core object, and D is declaring in page properties.
Yeah, data sly use in HTL. That's typically for bringing in Sling models or other JavaScript logic to provide data, not really for including whole components structurally.
Okay.
There isn't actually a standard HTL global object called core that lets you just pull in core components like that.
All right, that doesn't exist.
Nope. And page properties. That's metadata about the page, not for defining the actual components within the page template structure. So yeah, proxy components really give you that essential layer of indirection and customization that the others don't for using core components properly.
Makes sense. Proxy components in apps with Sling.resource supertype, that's the best practice for balancing reuse and customization. Okay, now let's think about managing content globally. Websites in multiple languages.
Question 6 asks, which AEM feature allows developers to reuse content across language versions while maintaining regional variations?
Hmm.
And the answer here is A, live copy.
Live copy, yeah, that's central to AEM's multi-site manager, or MSM. What makes it the go-to for this reuse with variation scenario?
The real power of live copy is how it creates these synchronized copies from your source content, which we often call a blueprint. When you change the blueprint, maybe update a core piece of content, you can roll out those changes to all the linked live copies. Keeps things consistent globally.
Okay, so updates flow down.
Right. But, and this is the crucial part for regional variations, live copy lets you break inheritance for specific parts of the content. So you can make local changes in your French site or your German site, tailor it for that region while still getting the main updates from the blueprint.
Ah, so you get both, central updates and local control.
Exactly. It's a really efficient way to handle multilingual sites while still respecting those important regional differences.
Okay, best of both worlds. What about the others? B is content fragments, C is experience fragments, and D is MSM blueprint. How are they different?
Okay, content fragments. They're great for structured, headless content. Think reusable text blocks, product info, stuff you might use across many channels, but they don't have that page-level sync and inheritance like live copy.
Right, different purpose, headless content.
Yep, experience fragments. Those are like reusable chunks of layout and content you can drop onto multiple pages.
Yeah.
Again, useful, but not designed for managing synchronized language versions with overrides like live copy.
Okay, reusable pieces, but not full site structures.
Exactly. And MSM Blueprint, that's actually the underlying framework behind live copy. It's the engine, the source structure. Live copy is the feature, the actual synchronized copy you work with to get this reuse and variation.
Gotcha. Blueprint is the source. Live copy is the synchronized, adaptable copy.
You got it.
So live copy, key feature for managing those complex, multi-language, multi-region sites, offers that vital balance. All right, let's shift focus again. How do developers add custom backend logic in AEM? Servlets.
Question 7. Which configuration should be used to restrict a servlet to a specific path and resource type in AEM? The correct answer here is C, at Sling Servlet Resource Types. Resource types, example components, selectors, esane.
Servlets, right, for custom APIs, backend stuff. This at Sling Servlet Resource Types annotation sounds quite specific. How does it help restrict where a servlet works?
What's really effective about @Sling Servlet resource types is it lets you register your servlet to handle requests for specific resource types. In this example, example components. And you can optionally add selectors, like JSON here. This approach really ties your servlet's logic tightly to the actual content it's supposed to process.
Ah, so the servlet only wakes up if the request is for that kind of content.
Exactly, or that kind of content with that specific selector. It leads to much cleaner code, easier to maintain, and helps stop your servlet accidentally firing on unrelated requests. It's a more content-centric way to define servlet behavior rather than just tying it to a fixed URL path.
So instead of just this servlet lives at bin my servlet, you're saying this servlet handles requests for this type of component, maybe asking for JSON. That makes a lot of sense organizationally.
Yeah, it does.
Okay, what about the other options? A and D are at component service servlet.class and at service servlet.class. They seem more general. And B is at Sling Servlet, by example, resource types, example components.
All right, at component and at service. Those are just the basic ways to register any OSG service, including servlets. They don't inherently connect the servlet to resource types or selectors in this nice declarative way.
Okay, too generic for this purpose.
Yeah. Now, at Sling Servlet, with the paths, property can restrict by path, and you can also add resource types there too. But at Sling Servlet, resource types is generally seen as more focused on the resource context. It offers more flexibility, especially with selectors and extensions. It's kind of the more modern preferred approach now.
Got it. So for robust, targeted backend logic, its Sling Servlet resource types is the recommended way. Ties the logic directly to the content it serves. Okay, let's switch gears one more time. Front-end performance, optimizing those AEM sites.
Question 8 is about that. How can a developer ensure client-side libraries are properly minified and merged in AEM? And the correct answer is dset, cq.combine true, and cq.minify true on the client lib node.
Client-side libraries. Yeah, CSS, JavaScript, they can massively impact page load speed. How do these cq.combine and cq.minify properties actually help?
Okay, so when you set cq.combine true on a client library folder, AEM gets clever. It takes all the JavaScript files in there and merges them into one single file. And it does the same for all the CSS files. This drastically cuts down the number of HTTP requests the browser has to make. Huge win for load times, especially on slower networks.
Fewer requests. Makes sense. And minify.
Right, then setting cq.minify true tells AEM to strip out all the unnecessary stuff, white space, comments from those combined files, makes the file smaller, quicker to download.
So let's have a 1-2 punch.
Yeah.
Fewer files and smaller files.
Exactly. Simple properties, big impact on front-end optimization.
Okay, sounds straightforward and effective. What about the other options? Is there just a single minify flag? Option A. What's the granite.minify OST service? B. Do page policies? C. Play a role?
Well, there isn't one single minify flag like that, but the cq.minify property does the job. The granite.minify OSG service. That is the underlying service that actually does the minification work. But you don't configure it directly per client lib.
It works behind the scenes.
Right. It's the cq.minify property on your client lib node that tells that service, hey, minify this one. And page policies. Nope. They're about the authoring experience, allowed components, styles. They don't control client lib optimization.
Okay, so it really comes down to those two Boolean properties, cq.combine and cq.minify, right on your client library folder.
That's the key.
Cool. Simple change, potentially big performance gain. All right, let's talk security now, a critical piece for any web app.
Question 9. What is a recommended way to secure the AEM dispatcher from allowing direct access to internal paths like libs or system? And the answer is A, define filters in dispatcher.any.
The dispatcher, right? That's the web server module sitting in front of the AEM publish, acting as a cache and a gatekeeper. Why are these filters in the dispatcher.any file so critical for security?
So these dispatcher filters in the dispatcher.any config file, they're basically a set of rules. They decide which HTTP requests get allowed through to the actual AEM backend publish instance. By carefully setting up filters to explicitly deny access to sensitive internal paths like libs, system, apps, you block unauthorized users from ever reaching those areas directly from the outside.
Because you definitely don't want people poking around in libs.
Absolutely not. That could expose system info, internal configurations, all sorts of things you don't want public. Think of these filters as a really strict access control list right at the very edge before requests even get close to AEM itself.
Like a bouncer at the front door, checking everyone's ID and deciding who gets in.
Exactly that. A very vigilant bouncer.
Okay, so what about the other security options mentioned? B is ACLs and CRXDE. C is blocking all GTs from unauthenticated users. D is enabling Apache directory listing.
Right. ACLs and CRXDE, those control permissions inside the AEM repository, who can edit what on the author instance, mainly. They don't protect the live public-facing site served via the dispatcher. Different layer of security.
Yeah, blocking all GGT requests from anonymous users. Well, that would break your public website entirely. No one could see anything.
Oh, right. Bit too extreme.
Definitely. And enabling Apache directory listing. That's actually a huge security risk. It lets anyone browse the file structure on your web server. You absolutely want that turned off.
Okay, so that's a definite no-no.
Big no-no. So yeah, dispatcher filters are the purpose-built, recommended way to lock down access to those internal paths from the outside world.
Dispatcher filters. Got it. The primary line of defense for the publish environment. Okay, final question. Let's go back to editable templates and their structure.
Last one, question 10. When using editable templates, what is the role of the structure layer? The correct answer is B, stores static content visible to all pages using the template.
Editable templates again. They really changed how pages are built. So this structure layer, what's its fundamental job? What does it let us do? So the structure layer in an editable template, that's where you define the fixed parts of the layout. The things you want to be the same across all pages made from that template. Think headers, footers, maybe a main navigation bar. Components that should always be there, maybe even locked so authors can't remove them.
Ah, the consistent framework for the page.
Exactly. Content you put in the structure layer gets inherited by every single page created from that template. It ensures that consistent underlying blueprint.
Like the page's skeleton,
Yeah.
providing that shared foundation.
Good analogy.
Yeah, okay. So how is it different from the other things listed? A was defining allowed components, C mentioned design properties, D was loading SPA components.
Right. Defining which components are allowed in certain areas. That's the job of the template policy, which is linked more to the content layer, where authors actually add content.
Okay, policies control allowed components.
Yep. Design properties like styling options for components also managed through design policies, and loading components specifically for single-page applications. That's a different architecture related to SPAs, not the core function of the structure layer in standard AEM templates.
Gotcha. Structure layer is purely about that static inherited content and layout framework.
Precisely.
We really hope this deep dive gave you a valuable shortcut to getting a handle on these critical pieces.
Yeah, absolutely. And as you think about all this, maybe consider how knowing these fundamentals really empowers you, right? To tackle more complex AEM projects, build cooler things. Was there one area today that particularly sparked your interest? Or maybe it made you think, I need to dig into that more.
Or even just thinking about how these ideas like modularity with components, performance tuning, security layering, how they connect back to your wider experience in web development generally.
Good point. These principles aren't always just AEM specific.
Well, thanks so much for diving deep with us today. We hope you found it useful. We'll catch you on the next one.